and welcome to this overview of the custom step Detect Data Drift. This step is intended to help you identify when your data is changing and then reacting on it appropriately by, for example, triggering an alerting rule that sends out an email or a Teams message or any other considerations that you might have. So let's take a look at how it works. I have already gone ahead and added a data set to my flow and also adding the step itself. Let's first talk quickly about the data set. In here, we have a number of different variables, both numeric, date variables, character variables, and we want to track them. Now, what is important for this detect data drift step is that you have a date or a date time variable within your input dataset that is used to compare different intervals against each other. In my case, this is the capture data variable. So let's get to work. We will connect our dataset as usually. Then let me move up the interface and we have to first select our date column. Here we are going to use the capture date column. Next, we can select the type of interval we want to use for comparison. And that means that we compare from today -1 interval to today -2 intervals to today -1 interval, and compare those two data sets against each other that are the baseline for the resulting data here. I'm going to leave it at weekly. Now let's go ahead and select the interval variables for tracking. Here you can select only numeric variables, but you can select a bunch of them, of course, at one time. And I'm going to exclude the bad and the custom ID variables here. Now we can select from the remaining columns the nominal inputs that we want to use. Here I'm going to be using bad, reason, and job. And I'm not going to be tracking custom ID, as pulling metrics from IDs doesn't really make a lot of sense. You might want to count them, but yeah. So I'm going to just exclude that one from my observations. Hit OK. And now we are actually already set up to run this step. So let's preview kind of what the result will look like and then talk about the optional outputs afterwards. So if we take a look at the output structure, we can take a look at the columns. And here you can see you get 60 columns as output. And one of those isn't a metric. The first one, the name, is the actual column name of your input data set that is being talked about in that row. So 59 metrics are collected out of the box for you that help you understand and gauge what you have in terms of changes within your dataset. Of course, not all of them are available for both interval and nominal variables. And if you want to know which are available for which, you can go into the About tab, where there is a list provided that specifies which ones are for interval, both, or only nominal variables. Okay, with that output data set, we can of course also look to the output options. The additional output options are all unchecked by default, meaning you don't get them. But you can use this to, for example, add visualizations to your output, where we generate graphs and distribution charts and also proc contents result to give you a deeper understanding about your data set. You can keep the transposed data, meaning both the data set just for the current interval and the baseline interval. So you have those as separate, not as an aggregated result if you need them. If you want to keep the actual differences between the old interval and the current interval data, just on how the nominal variables, what their differences are, there is the input for you here. And if you want to know the frequency distribution of the different categories of your nominal variables, you can make use of this last option. Note that the last two generate n output table, where n depends on the number of nominal variables within your dataset. So there's one additional table for each nominal variable. If we look back at this step, where we have 3, we would get 3 additional tables for each of these 2 options. Let me just select all of them here so we can see the maximum number of outputs. I'm also going to go ahead and add a table to my output just so I have somewhere to store this. And let's say results. And let's go ahead and run this step to see its actual results. Okay, here we are with our results. Let's switch over to the log. As you can see, we don't have any errors or warning in our log. Now, if, for example, you don't provide a proper date or date time variable, you will see a corresponding error notifying you. Or if there isn't any observations within the data set to compare variables against each other, then you also will be notified accordingly. Looking at the results, we get a very large amount of results here that you can scroll through on your own time if you are interested. But note that most of this is only generated because of that additional output that we set. And now let's finally look at the output data, where we can now note how many additional data sets we got, because the one we actually outputted into the flow was the work.results table. All the ones starting with _DDD, which stands for detect data drift, is here as from the additional outputs. So you can see the transposed variables, and then you can also see the outputs of those different categorical expressions and how they are distributed across each other. And let's just look at our result table here. You can see we got 13 rows corresponding to the 13 input variables into our step. And then we can see the different metrics collected. Note for that most of these metrics, actually it collects both the actual metric difference between those, always subtracting from the old interval, the current interval, and also a percentage change. Of course, both can be appropriate for you to monitor how your dataset changes over time. It's both pre-calculated for you if you need it. Let's keep continuing all the way to the right, where we can also see, for example, differences in categories between the 2 data sets. So here we don't have any. That's perfect and great for us to have an understanding of what's going on with, for example, category or variable. Now, one thing I like to point out is what, of course, you now could do in addition to just having this one-time result. You could just simply add an additional column to this results dataset and then append the datasets to each other to actually have a longer view of how things change over time, and then potentially visualize it in SAS Visual Analytics to create a more aggregated review of how a specific dataset changes over time. There's a lot of possibilities here of what you can do and help you to minimize times where you need to retrain your models or need to intervene into your ETL or ELT flows. I hope this custom step is helpful to you. If you have any feature ideas, issues, or other feedback, please contribute it using the GitHub interface for the custom step repository. See you next time. Bye bye.